hello, thank you for being here. And today, as John said, I'll be talking about how to select the right camera for your embedded computer vision project. So a bit of background, I do work for Digital Sense. We are a computer vision and machine learning studio with over 100 successful projects. We work with startups, with Fortune 500 companies in industries like agri-tech, geospatial, industrial inspection, and others. We have a very highly qualified team that includes 7 PhDs, 8 masters that have produced over 200 publications, 7 patents. So this is the team that enables us to be focused on R&D and innovation. That's where we provide value. And I invite you to visit us at digitalsense.ai, our website, in case you want to know more about us. Okay, so I would like to start the talk by addressing the motivation for it, which is that a well-designed acquisition system can be key to the success of a computer vision project. And I would like to illustrate that with an actual example. This is from an actual application, automatic defect detection in leather for quality control. This is a challenging problem because defects in leather can be subtle, can be hard to detect. The acquisition system here is key, right? And we have an example on the left there. We have a leather sample with a scratch. On the right, we have a detection of that suspicious area. And okay, if these were the kind of defects that you had in your application, this was the type of image that you had, okay, great, you're good to go. What you need to make sure of is that all of your objects of interest are clearly visible in your input signal, right? So in this case of leather detection, there are some important defects that need to be detected, like the ones on the right, like small punctures in the leather or small bite marks and so on that have a completely different scale. They are the scale of the grain of the leather. And in those cases, if your input image is the one on the left at that scale, at that resolution, it doesn't matter how sophisticated your machine learning model is to detect them, its performance will be subpar.